In this problem, we're asked to factor completely and we're not told how to go about factoring. So let's discuss that first. Anytime you're given a polynomial and asked to factor, you are going to first look for a GCF. This 9 is made up of 3's. There is a 3 in 30, and there is a 3 in 24. Now I'm looking at the letters. There's an x squared here, an x here, good so far, but no x here. So we do have a GCF, and it's 3. So before I do anything else, I'm going to go through and divide 3 out of every one of these numbers. And the answer I get will go inside the parentheses. The GCF of 3 is outside. 9 divided by 3 is 3. 30 divided by 3 is 10. And 24 divided by 3 is 8. So my new version of a polynomial is 3x squared plus 10x minus 8. Now it's very important to remember that this 3 cannot disappear. In fact, I had one student that gave us a tip. Go ahead and plug it in to the answer box and just leave it there so she doesn't forget to put it in along with all the other final answer pieces at the end. Now that we found the GCF and we have our new version of our polynomial, we take a look at it. We count the number of terms. This one is 3 terms. So for a 3-term polynomial, we have a few choices. We have a perfect square trinomial. We could have a table method, or we could have AC method with grouping. For it to be a perfect square trinomial, 3 things must be true. The first term and the last term would have to be perfect squares. The last term cannot be negative. The middle term could be positive or negative. So these are not perfect squares. That is not negative. And if those were true, this middle term would have to be 2 times the square root of that times the square root of that. So with all 3 of those things in this case, this is not a perfect square trinomial. The table method only works if the number in front of your x squared is 1, or stated another way, there's no number showing in front of your x squared. That doesn't work for us either because we do have a 3 there. So we are on the AC method, and that's just fine. AC method is the longer method. However, it would work on a problem that I could have used the table method for, and it would work on a perfect square trinomial. So AC method, if you can get that under your belt, you can factor most of the versions of a polynomial we are covering in this section. AC method is talking about the standard form of a polynomial, and it's referring to doing the multiply add table, but your multiply comes now from A times C. So my A times C is 3 times negative 8. So my multiply is negative 24. We are doing the table method. We're just doing more with it. We're doing the with grouping. So in table method, our add comes from that middle term, positive 10. I am going to do my methodical search for the winning pair that both multiplies to give me negative 24 and adds to give me 10. And that starts with counting. 1 times 24 gives me 24. 2 times 12. 3 times 8. 4 times 6. 5, nothing. Nothing times 5 will give me 24. My next one would be 6, but it's already been written down in my second column. When I get to a number counting up from 1 that I've already written down in the second column, I know I'm done. So I'm done right here at 6 and 4. So now I need to ask myself, what are the signs of those numbers? The sign of the multiply tells you if they're the same signs or if they're different. If the multiply is negative, then our signs of the two numbers will be different. So in this case, I know they're different signs. Once I figure out that they're different, then I look at the add and it tells me the bigger number. And that is going to leave, since they're different, it's going to leave the smaller number to be the negative one. So I'm going to put a positive on all my bigger numbers in my list of possible answers and a minus on all the smaller side of this list. Now I'm going to add these together, add in air quotes, because our rules for adding when signs exist means we could subtract if the signs are different. So I'm really combining these numbers, and since they're different, I'm subtracting them. -1 plus 24 gives me 23. I'm looking for 10. -2 plus 12, that one does give me a positive 10. So I have found the winning pair. I've found the pair that when I multiply, I get -24. When I add, I get positive 10. With AC method and grouping, I am not done. I now take my winning pair and turn this 3-term polynomial into a 4-term polynomial so that I can factor by grouping. I do that by splitting the middle term. If you watched Mr. Bachknight's videos and the video lectures with transcripts, you know that. So I take that, I rewrite this 3-term polynomial, except instead of writing 10x, I'm going to write minus 2x and then plus 12x. And my whole goal for doing that is so that now I have 4 terms, because with 4 terms, I can factor by grouping. Are you wondering where this 3 on the outside of my parenthesis went? It cannot disappear, but it gets messy when I'm trying to factor by grouping. We dealt with that when we put the 3 in our answer box. Another way to do this on paper is to draw myself an arrow to where I think I'll have the final answer and do the same kind of thing. Put the 3 there in my opening parenthesis for what comes next. So that 3 cannot disappear, but I'm not doing anything else work-wise with it. Back to factor by grouping. I group the first 2 terms. I group the last 2 terms, including the sign on that 3rd term belongs to that 3rd term. So it goes inside the parentheses. This did not magically turn into multiplication, so I'm going to insert that plus there. The GCF of 3x squared minus 2x, they both have an x. So I am going to divide both terms by x, but not before I write down that x, so I don't lose it. 3x squared divided by x is just 3x. Negative 2x divided by x is negative 2. Looking for the GCF of positive 12x minus 8. They both have a 4 in them. So I'm going to call my GCF for these last 2 terms a 4. Write it down so I don't lose it. Bring down that plus sign, that purple one. And now go back and divide by 4. 12 divided by 4 is 3. 8 divided by 4 is 2. So I have 3x minus 2. This is where I get to check myself and say, have I done this correctly or did something go wrong? And I know I've done it correctly when I can now divide out a common binomial. That 3x minus 2 is in both of those complicated terms. So now I have that GCF. I'm going to divide that out. 3x minus 2 and 3x minus 2. when I divide something out, I write it down. I know I'm on my last step, so I'm going to write that 3x minus 2 down here. And I have new parentheses for what the leftovers will be. 3x minus 2 divided by 3x minus 2. My leftovers are x plus 4. I think I'm done, but now I need to look at each individual factor, 3x minus 2, and x plus 4. And just double check, make sure there's not a GCF that I missed pulling out. Or is one of these binomials factorable even further? That does happen sometimes, but we're good. This is fully factored. So this is what will go in this box up here.